some more Charles Law practice here for you. Make sure we include here your formula right there. Makes me think we should move that down, and there we go. It's like magic. Okay, you should do this first. Remember, I'm just going to go through and do these ones a little bit quicker. So 1.75 liters should have been your V1. 9 degrees Celsius should have been your T1. Releases the balloon. At that point, the temperatures of negative 10 degrees Celsius should be your T2. At this point, what is the balloon's volume? So for your degrees Celsius into Kelvin, so first you do 9 plus 273, and that gives you 282. So your T1 is 282 Kelvin. And then you have to do negative 10 plus 273, and so that is going to give you 263 Kelvin for your T2. So that's the first thing you should have done. Then you can go ahead and set up your ratio. So your V1 was 1.75 liters. You did not know your V2, so that's just going to be X. Did not know your V2. And then your T1 was 282K. Whoops, K. And then your T2 is 263K. And then you just set up your proportion and you solve. So there equals like that. And then you cross multiply, of course, there and there. So you end up with 282X. And that is going to be set equal to 1.75 multiplied by 263, which equals 460. We're just going to round it to the whole number. Equals 460. And then you just divide by 282, divide by 282 right there. 282. And you end up getting for x equals, so 460 divided by 282, you end up with about 1.63. And what were we solving for? At this point, what is the balloon's volume? So if the temperature decreases to negative 10 degrees Celsius, what is the balloon's volume? It's going to be 1.63 liters. So we see the relationship continues in terms of the volume decreasing as the temperature decreases. So that's something, one way you can always check your work to make sure that everything is following that direct relationship. All right. Down here, we have a basketball is partially inflated to a volume of 2.1 liters. So that's going to be our V1. In a temperature of 33 degrees Celsius. So that is going to be our T1. How much could the volume change if the temperature increases to 40 degrees Celsius? So that's going to be our T2, and we're solving for V2. One important thing to note in the question, the reason why you should always read the question, it says how much could the volume change? Meaning we're going to end up doing some subtraction at the end. You'll see why. 33, first thing you should do is change those to Kelvin. So 33 plus 273. That's going to equal 306 Kelvin for our T1. And then 40 plus 273 is going to equal, I believe that is 313, right? That's all. Let's all make sure. It's always safe. 40, 313, right? Yeah, 313. 313 Kelvin. That's going to be our T2. Okay, let's set up our ratio. We have 2.1 liters. We do not know our other volume, so that's going to be X. We know that our first temperature is 306 Kelvin. Our second temperature is 313 Kelvin. So what would you expect is going to happen? The volume is probably going to increase, right? Because the temperature is increasing. There equals, so you have 306X. 306X equals, so 306X equals 2.1 multiplied by 313, and that's going to give you 657.3, and then you just divide by 306 divided by 306 divided by 306. Throw that in there. 306. 306 divided by 306. It's going to give you 2.15. It's going to give you 2.15 liters. But is that our answer? No. Typically it would be, but it's saying how much could the volume change? So we started off with 2.1 liters. We ended up with 2.15 liters. So how much did it change? To know that, you'd have to do 2.15 minus 2.1, which is what we started with, and you will end up with a change of 0.05 liters. It increased by 0.05 liters, and we did that because it asked how much it changed. So the answer you should have gotten for that question is 0.05 liters. Charles Law, living the dream. Farewell.